Welcome to Wise Guys Unprompted. I'm Zachary Kreider, joined by my co-host, Martin Holstay. Here we cut through the noise and get real about AI and cybersecurity. No fluff, just insights that matter. Each episode, we break down the latest developments, decode complex topics, and share unfiltered perspectives on how AI is reshaping security. Whether you're a CISO, security professional, or just curious about where technology is headed, we've got you covered. So let's dive in. Welcome back, episode 3. This week, right? So we'll kick it off. We have a special guest today, which we're pretty excited about. And Martin, you want to introduce her?
Yeah, absolutely. So I had the pleasure of meeting Kyla Guru a few weeks ago at Intellicon in Austin, and I loved her work and her messaging, and just thought everyone should hear about it. So without further ado, welcome, Kyla.
Thank you guys for having me. Excited to be here.
So Kyla has been, she graduated from Stanford. She's continuing her studies there, and she's also at Anthropic. So we have a lot to talk about with Kyla today.
Indeed, yes.
All right. So first and foremost, I was really impressed with your research. Is similar to things that we've been doing here, but very different angles. Do you want to talk a little bit about your thesis that you've been working on at Stanford?
Yeah, 100%. So last year, so I recently joined Anthropic, but prior to Anthropic, I was doing research at Stanford in the Stanford Intelligent Systems Laboratory. And I was specifically working on a project that looked at evaluating LLM's ability to do threat intelligence tasks, specifically focusing on tasks related to like TTP identification from unstructured threat intelligence documents, and then whether we could use some of those TTPs to conduct attribution. So I ended up building an end-to-end pipeline that basically took in a document, extracted TTPs from that document, and then conducted attribution using more of a classical machine learning model. But the whole process looked at, can we actually use LLMs to build out these more efficient and potentially informative workflows for doing more critical decision making and security.
Yeah, that was amazing. And I think your research hit on a couple of key themes that I feel like are surprises to a lot of folks. And one is that most LLMs, and especially LLMs from Anthropic, have things like the MITRE ATT&CK framework already built in. And so it already has this general security knowledge. And this kind of been something I've seen a lot of people do is think, oh, I got to do some fine tuning or extra training to tell the LLM about security stuff. And actually, it's really the just specifics like what you're describing that you really have to talk about with the LLMs. And so I thought that was an interesting area to be able to say, how do you leverage that general knowledge that's already baked in to say, okay, now that you know this, what would you think about this clue and this clue and this clue to kind of put that together? And that's something historically, I think, just attribution in general is always an interesting topic. So that's really cool. What kind of strengths and weaknesses have you seen on some of the LLMs? Like, where do you have to give it extra prodding, or where has it surprised you on its ability to tie things together?
Yeah, I mean, like you said, I think the generalized knowledge is really, really cool to see in action. Even as you give it more information, a real investigation would look like, as you gather more and more clues or hints as to what's going on in the system. For example, if you give it a bit of malware or the name of a malware file that you find, or even terminal commands that the threat actor might have sent in, it's able to sort of use those alongside its deep knowledge from generalized intelligence to kind of see have a better understanding and even act as a decision support tool in many instances. So definitely really excited about the capabilities of these models to add another perspective and to act as a junior analyst, some might say, in helping with certain decisions in security. So I think that's the part that I'm really excited about.
Yeah, and the previous episode showed the actual stats between junior analyst and senior analyst, and in some cases even LLMs acting as better than a human. Certainly in many cases it doesn't, so it's still a frontier out there. But I think that's the interesting mix about where that line blurs around, and I think attribution is a great area for kind of showing that, because it's so human centric, where it's really looking at what kind of human performed this action. So is there any particular themes that have popped out in your research there?
I think just underscoring what you're talking about there, Martin, is like there is such a humanized element to it. So even though a model, might know a lot about various threat groups and their historical patterns, etc., it also takes like a human to go in and say like, oh, but I know this threat group is like particularly active right now, or this threat group really likes to target this specific industry or sector, so we should look there and we should further our search there. So I think that's where like the human touch becomes super important, and like the expert prior is what I called it in the research. And that I found really, really boosted the results a lot and helped with the attribution decision making. Just even being able to put into the model like here are the threat actors that are active right now. Here are the ones that are a bit more dormant that we haven't seen act in years or months. So yeah, I think just underscoring the human element.
So how are, and maybe this isn't possible yet, but did you have any ways to check to see if it was like scoring its decisions, or how did you know it was making the right attribution? What were the kind of evaluations you did for that?
Yeah, so for that piece, I chose specifically instances and cases that the model hadn't seen before, and had asked it to make attribution decisions on those cases. So it was basically just a pretty date driven thing where I was like, where is the training cutoff of the model? Let me choose instances, or let me choose these incidents that happened after that, and then basically fed the model the document with like redacted components of where the threat actor was spoken about, and asked it to first pull out the TTPs that were relevant from the attack. And I was mostly looking at like, can we just start super simple and try the simple thing that works? So I tried to just take the TTPs and do attribution based on that. And obviously, like how threat intelligence works in the real world with attribution, TTPs are only one piece of the puzzle. So there was kind of an obvious like performance boost when I added things like the expert prior, or like when you look at like the victim country or the victim industry, there's a lot more you can do there. So I was looking at TTPs as a way of just showing that just using raw behavior, we can actually see some model performance there. Raw behavior of the threat actor, I mean, because those are things that are less ephemeral. Things like IPs can be switched really easily. So looking more at the TTP level seemed to be a better approach to me.
Gotcha. Yeah. A long time ago, I worked with a guy named David Bianco. Shout out for him. He invented something called the pyramid of pain around TTPs.
Yes, and, I cited him in my thesis, actually.
Yeah, David's fantastic. And hi, David. Hopefully see you again at a conference soon. But yeah, he pioneered a lot of that, and his whole point was how easy it is to swap out things like IP addresses and some of the more ephemeral pieces. But I think that's what your work is really showing, is the value of LLMs for being able to pull out some of those things at the top of the pyramid, which are so much harder, right? Mm-hmm. And those kind of deep aspects in whether it's timing or types of language being used and things like that. So I think this is, as we're seeing everything really, this arms race where things are shifting forward, it's going to be, I think, really interesting to see where the false flags are and things like that in operations. Just switching over to a different language is suddenly super easy because you can, have all the commands in any language you want, anytime you want through an LLM, right? You can say, okay, rewrite this text in whatever. And I think that's going to be pretty interesting to see how quickly that's taken advantage of. And then on the defender side, how do you coach the LLM through that attribution to say, don't necessarily take this into account or this into account, look at these angles. Is that something you'd already looked at, or something in your future research, or where are you there?
Well, I think the research did somewhat show like some of the biases of the large language models, like because they're trained on all of this data that's like existing in the public internet. It's obviously kind of like steered towards choosing groups that are more well represented within that open internet data set. So I would hit like a lot of just the main like cozy bear, fancy bear adversaries because they're so publicly known. So I did kind of make a case even in the IntelliCon talk about, can we figure out ways to put out more, even to select groups of researchers looking at this issue, more intelligence reports about these other adversaries, just to enrich these data sets and make these make these systems more accurate, to be honest.
Yeah, it's really cool.
And so like, what led you to actually do the research? Like, I guess background of like, how did you get started with this and what was kind of the idea behind it to go down this path?
Yeah, I mean, it's really interesting. I think I started my thesis year being like, I want to do something in AI and security. And I didn't when you start, you realize that that means like a million different things. Like, so then I think I just started talking to a lot of folks. I'm specifically interested in like national security related decision making in cyber. So I think that's where like attribution felt like a very natural issue area to look at. It's also been like a very big pain point in the cyber ecosystem for a long time. So when I got to talking to some of my mentors who used to do this kind of work in government, it seemed like there was a process to it, at least on the technical side, where they were like, this is the pipeline, this is step one of the incident response. Like, this is how we put together this diamond model to understand like what the threat actor was trying to do. And then from here, we make these attribution decisions. So based on the fact that it seemed like an actual like procedural approach, I was like, oh, maybe, this seems also so language heavy in terms of like the reports that are written by forensic analysts and what is going on, that I was like, when I looked at the previous literature, it seemed like a gap was just looking at how LLMs would perform on this task. Like there was some prior research on how neural networks would perform or other traditional like machine learning type algorithms, but there wasn't any like emerging research in that area. So it just seemed like kind of a gap that was needed to be filled in such a language heavy area.
And I'm just curious, like when you were talking to those folks, right? Like time's also like the biggest thing in security of like how fast you can respond. So, I mean, when you went through those processes, like how long on average do you think it took them to go through one of those processes versus like your research when you use the LLMs to actually do the research and write-ups? Like from a time saving standpoint, kind of what did you see?
Yeah, I mean, this is an interesting question because even within attribution, you have like technical attribution, but then there's also like public attribution. Like there's different definitions of attributing a threat actor. So on the technical attribution front, it sometimes takes like attribution in general, like takes like months to years sometimes, even just to get a picture of like who the adversary was, and then figure out with our international partners, like what are we going to do about it? Are we going to go out and be public about it? So the reason for the delays in like the non-technical side of attribution is because these other nation states don't have the tooling required to like conduct attribution as quickly. So, and typically like attribution is something that's agreed upon by several different countries. Like each country likes to do their own kind of process and then come to a conclusion and then cross-check that against a lot of other partners. So, and that was like the motivating thing there is like, oh, if this is the pain point where many countries don't even get to a decision on the technical attribution front in order to even come to that step of doing that like more legal attribution or public attribution on the diplomacy front, then maybe we should solve for building these tools to be like more I guess like more public in the civic sphere.
Yeah, really democratizing that capability.
Yeah, I mean, even like democratizing the ability to do some of the subtasks is important, like outside of attribution, like even just looking at, like you were saying, Martin, like the subtask of TTP identification is just like a very language heavy task. It is something that LLMs have a lot of potential for. So like, I think that's what's cool to me too, is there's so many applications like beyond just attribution as well.
Nice.
Absolutely.
And you're getting to like reverse engineering or taking actually code, like malicious code and having the LM try to reverse engineer it. I mean, did you go look at any of that in your research?
I haven't looked at it in a like researchy systematic format. It seems like a really interesting area to explore though, especially with the more like capable models 3.7 that just came out. So I think I'm very excited about those applications. When I was doing the research, like I thought about using malware as like one of the ways to do attribution. Also, like some research and background information pointed to the fact that like even malware right now is like shared between threat actors. It is like leaning more ephemeral, interestingly. So the fact that like we have malware as a service now, things like that make malware like a less high fidelity indicator than it used to be. So that's why, again, I was steered towards a different direction. That plus like there's a lot already out there on like using basic classifiers to run like Cuckoo Sandbox and look at malware as it runs and then do some classification based on that. So it's a cool area, malware reversing. I don't know, have you guys also looked into that at all yet, or?
Yeah, originally in the early days of Claude coming out, like we kicked off a project of trying to take mobile malware and just trying to throw it at Claude, for example, just have it do reverse engineering of the malware to identify like anything malicious in there, and then just how's the code structured and be able to explain that to an analyst. Where on average we saw an analyst maybe spend, let's say, an hour, right, that they'd have to go through a piece of mobile malware. And Claude was able to go through the whole thing, do a full write-up, tell like where in the code that someone should go look at in about like 30 minutes, right? So, I mean, that was the early days of Claude, right? Things have gotten better since then. But we were really impressed in the ability for it to just read the code and just understanding kind of if you gave it guidelines of here's the stuff you should be looking for or malicious intent potentially in the code, just identify it and its ability to be able to call that out and do a write-up for an analyst where they can quickly go back in the code, go, oh yeah, this is right, you're right on the right track, and help the analyst kind of quickly come to a determination if it was good or bad.
Yeah, and that's one of the areas that really accelerates because it's read the entire internet, right? So it's a complete expert on anything it comes across. So whether it's, oh, I need to understand this language, no problem. You don't have to like figure out the translation, anything, any encodings or obfuscation, it understands that kind of stuff, which is a really big deal. But just being able to give it like our OS change report, which is the output from our sandbox, fully understand that, and then understand any of the libraries involved, whether they may have had CVEs themselves, that kind of stuff, all within that same bit of analysis. Is so powerful with it. And then just the general coding abilities. So it doesn't have to, you don't have to go out and script a bunch of things. And that's, a lot of time that you don't have. And that's an investment, right? That you would have to make a calculation up front. Okay, is this sample worth doing all this extra work for versus giving it to that automated process and having it do that level of detail? It's very similar to the stuff I was talking about earlier with just event analysis. It's the same, right? Being able to get that deep in analysis means there's just fewer and fewer places for people to hide and, put, additional things, roadblocks in front of that overall analysis. So that's the encouraging part after talking about the discouraging part where attackers can do very similar things as well and throw, false flags and things like that in there if they want to. So yeah, I mean, I haven't gotten into deep fakes. That's a whole other area, right? So yet another thing is in my local paper today, some poor grandmother was duped out of her money because they deep faked her granddaughter, needed help and all that stuff, right? Nothing new there, but just to see the different tooling and how effective it is, you see that all over. So it's perennial arms race, making sure everyone's, upping the ante here, because you're definitely going to get left behind if you don't have some help to figure this stuff out. You'll have absolutely no idea what's going on.
Yeah, no, I think the key point there is like it's the democratization of these technologies will be very important, and ensuring that like we're not leaving anyone behind. So I'm really motivated that like defense companies like y'all are picking up this technology and trying to run with it and see how it works in your environment. So that's very like empowering, and I eventually think that like the defense improvements that we see will be like tremendously impactful in reducing our general attack surface as a community as a whole, I guess.
Yeah, I think we've been talking about like a skill shortage now for like the last 20 years.
Oh yeah,
and no one ever solves it. Like someone just creates a new solution that creates more events that just adds on to the problem. And I think, a lot of the research we've seen with LLMs, like it kind of seems like that might be something they'll be able to solve, or at least close that gap a little bit, just because it's able to do more that, humans aren't available, right, to do those jobs today, right? So it should definitely speed up, especially for the SOC and research portion.
Yeah, absolutely. I was just going to say, I think that's why it's so important to actually have benchmarks on these tasks that you guys are working on actively, and have that kind of research out there in the world, so that folks can actually have like data-backed tooling and science-backed reasons for adopting these tools. So I was just gonna like plug your guys' work in that space and plus one on that.
Yeah, that's what I was about to say is I got this question from someone. They said, well, how can you vouch for the code that's coming out, or, the research that this thing is an LLM they're referring to is going to put out? And you can't in a lot of ways because it's non-deterministic, right? But you can at least say 99% of the time it's going to be correct, and you have these QA processes in place to verify it, things like that, right? But you've got to have a framework to match those things up and ensure that you have a way to double check it. And then obviously you want to start with the best that you can in the first place and have those. That's why those benchmarks were so important that I was showing earlier, to figure out, okay, what is our best bet here? And then, what do we do if it's wrong? Right. And be able to check that. And honestly, at that level, it's no different than working with humans, right? You're saying who's the best person for the job and how can we make sure they didn't screw up? So you think of anything in transportation, same deal. Obviously, self-driving cars, very similar question there around, okay, it's right 99.9% of the time. What's the cost of being wrong? Same with air travel, all that stuff. So I think we have frameworks, mental frameworks anyway, to work on from a risk management perspective that I think will be even more important as we go forward, as we start to trust that stuff. And now we're getting to the point where I'm just today I was working with Claude 3.7 and it's doing stuff that I don't know how to do. So it's like, okay, how do I verify the output of this? And see that a lot in bioengineering, and we're just this year. You're going to see a ton of this where we have these expert models that are going to come to these new discoveries on their own. And it's going to be a question of, well, how do we validate this stuff? And then it's like, okay, create a test framework. But it's going to be this really interesting frontier here for humanity as we see stuff that's going beyond what we can do for our benefit, of course.
Yeah.
So it's going to be interesting. But those are the big questions we got to answer.
Yeah. I mean, I think it just underscores the importance of human in the loop right now, and why it's so important to have to still gain subject matter expertise in these areas and bring in that perspective. I just think that having somebody who can, like you said, Martin, look at outputs, validate outputs is important, but also just make these higher level strategic decisions still, and use these tools to assist, but to rely on their intuition alongside the machine's production of information. That's the important balance we need to strike.
Yeah, well, I think we're getting pretty close to these certifications and things like that. There was just some research out this week showing how easy it was to poison code generation with just a little bit of fine tuning. Will introduce vulnerabilities on purpose into code. So if you said, if you use the wrong LLM, it'll spit out vulnerable code, but it won't even know that it's spitting out vulnerable code. It was basically tricked into doing that. And that's this whole supply chain backdoor, and saying, well, if I can get people to use that LLM, they're going to start shipping code that I can go in through backdoors and start hacking places. It's crazy stuff going on now we're seeing. But that's just another example of why you got to trust the LLMs that you're using, because you're relying on them more and more for all of this stuff. So it's kind of an old story, but very new and more broad, I think, discussions for it, and a lot more at stake than there was even just weeks or months ago, honestly.
Times are changing so quickly.
Yeah. Speaking of which, so you talk about this stuff like you've been doing it for a very long time. I think I learned from your talk a few weeks ago, your background. I think it'd be great for you to kind of talk about that. It's really interesting to hear how you got your start way back then.
Yeah, no, happy to do so. I have probably the most unconventional background for this space, but I actually started when I was in high school. When I was a freshman in high school, I started a nonprofit that was focused on K-12 education and cybersecurity. And that nonprofit still exists today. We still do that good work. And it was very much focused around increasing advocacy and awareness in K-12 schools about different cybersecurity and digital privacy topics. So just ensuring that, like we were talking about all along, that we're not leaving any community behind in this technological revolution. So any free time I had from school, I would basically spend in senior homes and K-12 schools and teaching education workshops and teacher conferences, talking about our curriculum. And we kept putting out this free curriculum in cyber. And one day I kind of just got really curious, and I was like, why is this happening? Like, why do threat actors even care about attacking like civil society and targeting people? So I moved more towards the threat intelligence side, and I was at the MSISAC for about a year doing like threat intelligence work. This was in high school as well. And then went and kind of hopped around, did like product security, did government for a little bit, and I worked at CISA and did international policy, and then was at SpaceX doing like some of their government work, and then just recently hopped over to Anthropic to be here full time. So kind of a wild journey, all, but just kind of highlighted to me that cyber is like such an expansive space and needs people with such diverse perspectives. Like even if you're interested in psychology or forensics or crime in general and helping victims, like there's a space for you here. And like you said, Zach, like we are definitely experiencing a shortage of folks. So we really need all the help we can get. So anyways, I think that ended up becoming a plug for why people should join cyber and join us in our adversary fighting. But I've loved cyber throughout, and I think there's so much to do.
I missed the MSISAC angle to that. I worked with the Multi-State Information Sharing and Analysis Coalition quite a bit back when I was running the SOC for the state of Wisconsin. And
okay,
yeah, that was a very active group. And those, back to the democratization of that, having those coalitions like that, and there's, the FS ISAC and all the different ISACs, but having those working groups that get people connected and understand, oh, wait, you're getting attacked by these guys too.
Yeah.
That's really important stuff. And I'm glad you had that experience, but it's not a surprise to me that really catapulted you to say, hey, these threat actor things are really important. You get to see stuff from that angle.
Right. And I think it was like a natural transition, because I think one thing people don't realize is that the MSISAC and those ISACs actually have like a lot of free resources that can be used in the community that you can just deploy on your system as a local state government. So that was really cool to go from like advocacy and education in cyber to like more of a technical role, but still being like out in the community and showing that we have these tools that are just really just meant for the betterment, like no other purpose of like making money or anything. So, but in general, I think there's so much to be said about like defensive tooling right now and how it's going to be augmented by AI.
Yeah, very cool. Man, well, I feel like we go for like 3 hours on all of this. I'm going to need some sort of refreshments though to keep going.
I know. Yeah, I could chat forever. This is really awesome though.
Yeah, so we got that's the one fun question, right? So everyone saw the benchmarks about Pokemon and Claude 3.7. So like, what is your favorite Pokemon and how far have you gotten in the game? Or are you just watching the Twitch channel and watching Claude go through the game every day?
I'm more of an observer right now, I will say. It's just so fun to watch like the Twitch. We have that running on like screens here too. Just like, so we've had like a lot of just discussion about that, and that's how like we open the meetings, just checking in on Claude and how he's doing. But yeah, it's fun. I think it's cool that we can showcase demos like that relates like everyone in society, and it just goes back to like democratizing this tech.
Yeah, it's great for kids. So I've got a 14-year-old, and this is the most interested he's been in AI in a very long time, watching the Pokemon demo. And then I showed him a webpage that Claude created, and he's like, whoa, AI made that? And I'm like, yeah, I just told it to these 3 words, make the page look like this. And he's like, that's incredible. So I think it's really good to have, for kids that were raised on TikTok, for something a little bit flashier and more in their face to say, this is technology too, right? It doesn't have to be just boring, low level code stuff. It can be more human level. So I think that's pretty interesting. Absolutely. Very valuable, and helps that skills shortage that we're talking about.
Yeah.
There you go.
Cool.
All right.
Well, thanks for joining us and talking with us today. Definitely look forward to all your work coming out, your research paper, finally from on your master's program. But thanks for joining us and talking with us today.
Of course. Thank you guys for having me. This was awesome.